At TAMUCT, we have a small department that pays attention to individuals. We're also very practically focused, so we're in a good position to give our students opportunities for hands-on experience. Now more than ever, math is an essential part of technological work. Math works together with computers to enable you to understand what's going on and make systems work better. Let me show you a couple of examples. Here's a simulation of a four-way traffic intersection. It's set up to represent an actual road intersection in the city of Kaduna in Nigeria. Let me start it so you can see how it works. You can see the vehicle stopping and starting at the traffic signals. The simulation runs in Sumo, which is a programming environment written especially for traffic simulations. The traffic flow and the traffic light durations are controlled using the Python programming language, which is currently the most widely used software used for development. Let me show you the program. It's about 500 lines. The simulation is being used to design a smart traffic light control system that will allow maximum traffic flow and reduce drivers' waiting time. One area where math plays a key role is modeling and simulation. Modern engineers typically use computer simulations to test out their ideas before they build actual systems. Here's a simulation of a wireless sensor network. These are used in environmental and military applications. The grid of squares represents an area which could be a few kilometers across. And at each intersection point is located a sensor that is listening for targets. The four magenta diamonds indicate targets, which could be planes, drones, intruders, animals, etc. Each sensor can sort of tell how far away the targets are by how loud the signal is. But the individual sensors can't tell the direction or even the number of targets. All of the sensors transmit their information wirelessly to a command post where the information is combined and put into a computer. The computer uses mathematical algorithms to estimate the target's positions and uncertainties. The estimated positions are the yellow stars, while the colored clouds show the uncertainty in the target's position. Let's see how it runs. You see that the yellow stars are tracking very closely with the actual positions of the targets, even when the targets move close and then move far away again. This particular system was designed for the U.S. Air Force and uses MATLAB, which is an industry-standard mathematical software.
Join our department and become part of something great. Connect with us today at tamuct.edu.